lessons that's kind of all over the place. And so I thought it might make more sense to just go over a couple of them with you. We are just on the cusp of getting where things get a little crazy because you have to remember how to factor. And the factor in the trinomial one was really friendly in our quiz, just barely. But we're going to start getting into some of the bigger, yuckier stuff, and that's why it's hard, is because you don't remember. So we are right there, and the last 3 or 4 have some factoring, and I'll show you what we need to do. I hope these are friendly. We've been doing these for quite a few years now. Let's just do this one, because why not? Why am I plugging it into the second function and not the first? Because it's G. Okay. Order of operations is the only thing that kills us here, I think. 2 times 16, what was I supposed to plug in right there? Sorry about that. Plus 12. 32 plus 12 is 44. You guys would see that problem and you'd be happy about it? Wouldn't hurt your feelings? Good. Are you okay if it tells you to put an expression in for x? Is that new or is that old? I can't remember. Give me some feedback here. It's new, we think? Yeah. Okay, let's look at it then. So plugging numbers in, substituting numbers was no big deal. And this is along those lines. If this is newish to you, I like to put all my variables that I'm going to replace in parentheses, because that reminds me I'm going to substitute something in there. What is it going to be in this case? 5a. So I'll say 7 plus, all right, replace that x with 5a, over 4 plus 2 times 5a. 7 plus 5a is over 4 plus 10a. That's as simplified as that one will go. Now that you see it, what do you think? I see some eyebrows over there. Is there a question? Cambry? Just kind of, okay, whatever. Would you guys like to see another problem like that?
Wait, so you don't reduce the 5?
You want to reduce the 5s. So remember when we were dividing polynomials by monomials, and we could only cancel things when every term had the same thing? Does 5 go into 7? Does 5 go into 4? Right? If I want to reduce this fraction when it is a sum in the top or the bottom, or a difference, you can only reduce if every single term in both expressions reduced by the same factor. So that is simplified. I'm glad you asked. That was a good question. So that being said, can I reduce that one?
Yes.
By what? Everything would reduce by 2 here, right? And in this case, I could factor that 2 out of everything. Okay. Done there. Let's see what else is in this homework. Those are the same. You're good at that. That's what we just did. Reducing was the hardest part, it sounded like. Okay, you've seen this before. It was a year ago. And once I remind you how this works, it's no big deal. Put it in descending order. Okay, so what is the term with the biggest exponent? That. Now, you're going to just do this in your head. But because the video camera can't see in my head or your head, I'm going to write it out. And it's in descending order. Once you've got that, the leading coefficient is whatever number is in front. So in this case, my leading coefficient is negative 23. And my degree is the highest exponent, which is what?
8.
8. So as long as it's in descending order, super easy problem. Okay. Degree and leading coefficient is going to be pretty important later on. What is the degree of this one? We're not going to rewrite it. Do it in your head. 6. What's the leading coefficient? 4. 4. Good. Hey, we're getting bigger and bigger polynomial functions here. So in this case, it wants to know all of the real zeros. You guys remember what zeros mean in a function? We graphed a parabola on our quiz. And did it sit down here? Let's pretend like it did if it didn't. Okay, it sat down right there. Where it crosses the x-axis, those are known as the zeros. So here and here, what does your y equal? 0, right? We're on the x-axis, so that means our y value would be 0. So let's look at these. If I want to find my values of x when y is 0, what am I going to replace that f of x with? 0. Okay. We love that this is in factored form. It is our best friend when it is factored form. Because you remember that phrase, zero product property? No. All right. If I have, so taking a detour from that problem, let's say I have 2 numbers. And when we multiply them together, they equal 0. Okay. If b is some number, what would x have to be? 0. Okay, other way around. What if x is some number? What would b have to be? Because however I do it, one way or the other, one is 0 or the other, when I times them together, what does it equal? 0. That is the zero product property summed up pretty tightly. Same thing. If I'm telling you all of these things times together equal 0, one of them, if not all of them, can be set equal to 0 and solved. All right. What is x here?
0.
0. What is x here? How do I get rid of the squared? Some of you are going to be stuck on that for a second. Once you see it, you're going to be able to do it in your head. How do I get rid of the squared? Square root. All right, so now I'm to x minus 9 equals 0, so x equals, do that one in your head. What does x equal? 3. So I've got 1, 2, 3 answers here. Questions? Okay, we'll do the next one without writing anything down then. Find all the zeros of the function. 5 equals 0. Does that make sense? Let me write that one down actually. Here we go. We've got 5 equals 0. Is there anything to solve for? So don't even worry about that one. What's my answer here?
2.
2. Here. Negative 2. Here. Ooh. Whoops. Let's fix that. It is 1. I'll give you that. So this was tricky. Help me solve for x. Should we add 1? How do I get rid of that square? All right. Now, you've got to remember when I'm solving for x, and I had an x squared, and I just had to take a square root. I didn't do it on 0 a second ago because plus or minus 0 is still 0. But do you remember what's 1 squared? 1. What's negative 1 squared? 1. So don't forget your plus or minus when you're solving for x right there. So how many answers do I have here? 1, 2, 3, 4. Okay. Let's remember how to factor a little bit. Did I say 13 or did I say 14? Find all the x and y intercepts of the graph. X-intercepts, that's a fancy way of saying the zeros. That's what we've been doing, right? So let's start with that one. What did we do with our y so we could find the zeros? We let it equal what?
0.
All right. 0 equals. I can't do this unless it's factored. My recommendation is to first look for a greatest common factor. Is there one in that polynomial?
2.
All right, let's factor that out. Make our lives a little easier. Okay. Does anybody remember how to factor a polynomial with 4 terms?
Grouping.
Split it up. Yeah, split it in half by grouping. I'm seeing all kinds of hand motions, and that makes me so happy. All right, we're going to split it down the middle. We've got this 2 out here. I'm going to have to remember he's here. Greatest common factor on the left-hand side is what? X squared. X minus 1. Greatest common factor on the right. Okay, why are we going to use a negative 16? We want to get rid of that guy, right? So minus 16, and I've got x minus 1. What do you notice that we have in common? All right, so I can now rewrite this. My 2 is out there. I've got a greatest common factor of x minus 1. And then I have left x squared minus 16. Hey, you think you're done? And you're not. What do you recognize this as? And can you factor it? Difference of squares. If you don't see it that way, look at it. Are there 2 numbers that multiply to be negative 16 that add to be 0 because our middle term isn't there? Negative 4 and 4. So this guy would factor to, let's change colors again, why not? X plus 4, x minus 4, 2, x minus 1. Goodness gracious. Hey, it wants the x-intercepts. Now that I finally have it in factored form, what makes that one 0? 1. What makes this one 0? And this one.
4.
Whew.
So where does the 2 go?
Okay, same thing. 2 set it equal to 0. Is there anything to solve there? So that is not one of our intercepts. Good question. I did the hardest one first.
Scale a graph, it doesn't change the intercepts.
No, does not change the intercepts. It's a good way to look at it, for sure. We'll graph later, though. How's that? Yeah? All right.
I think I pretty much just graphed it in my head.
All right. Y-intercepts. If we found the x-intercepts by letting y equal 0, what are we going to do to get the y-intercept? What are we going to let it equal 0 this time? X. So that would be a 0, that would be a 0, that would be a 0. Those would all disappear. We could do that in our head. What is our y-intercept? 32. So is the factoring the hardest part? Yeah. Would you like to see another one or attempt it on your own? See another one. You say, okay. If you're ready to start it, I think it's open. If not, sorry, you're going to have to wait for me for a second. Oh, no. Okay. Does this have a greatest common factor? No. So I can start factoring here. Split it down the middle. Greatest common factor on the left-hand side is what? X squared. After I factor out that x squared, I would be left with x plus 3. Greatest common factor on the right-hand side. -4. Divide both of those by -4, and I'm left with, the factoring is going to be friendly today. If you don't get a matching something, you did it wrong. Okay, that is your check. Do they have an x plus 3 in common? So I can factor it out as my greatest common factor, and I'm left with x squared minus 4. You recognize this as a difference of squares? 4 is a perfect square, so is x squared. If not, find two numbers that multiply to be -4, but add to be 0. 2 and -2? Okay. What are my x-intercepts? What makes this guy 0? -3, this one, and this one. All right, now to find my y-intercept, I let the x's equal 0. Here, here, and here, which means those would all disappear. And my y-intercept is -12. When you're stuck, just holler at me. I'll come sit with you.